Good morning, students. So now today integration, and yes, today maybe the last of this of integration class. Next day I will take this your next chapter. So now I have written because one time I failed to record the video due to some heavy shower and this. So now as I have done, so you see this one I have written question number 19. Integration sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x dx. Here we will use one formula that sin inverse a plus cos inverse a is equal to 90. So if we put denominator as this one and numerator in place of cos inverse a, if we put cos inverse root x, we can put pi by 2 minus sin inverse this one. So that will give 2 sin inverse root x minus 90. Now, if I isolate this by that, then we get this form. Then one substitution we do, let x equal to t square. Yes, if we put x equal to t square, then dx will be equal to twice t dt. 4 by pi sin inverse, as x is t square, root x will be t, and dx is twice t dt. Integration of dx is x plus c. Now 2 taken outside, it is 8 by pi sin inverse t and then t. T into this we will use integration by parts. So this I have taken as first and this one is second. So first into integration of second minus derivative of this one into integration of t dt and minus x plus c as usual. Then I have written 8 by pi sin inverse t written here. Integration of t dt is t square by 2. Differentiation of sin inverse t is 1 by root over 1 minus t square. Integration of t is t square by 2. Half I have taken outside minus x plus c. Now t I have here, this one as usual I have kept. Then minus t square, I have taken minus 1 in this place. So plus it is minus t square, and then I have added 1 and subtracted 1. Now we have replaced t by root x. So this term t square will be x sin inverse root x. This one we can write after this withdraw of this bracket. 8 by pi becomes 4 by pi, 1 minus t square by root over 1 minus t square. So it will be definitely root over 1 minus t square dt. And minus this will give 4 by pi dt by 1 minus t square minus x plus c as usual. Now this one 4x by pi sin inverse root x 4 pi. This is formula integration root over s square minus x square. It is x by 2 root over s square minus x square minus half a s square by 2 sin inverse x by a. That formula I have used, and we get this one. Only integration of that one is this, and integration of this one is sin inverse t. Then by replacing x as this one t square, we will get our requisite answer, this one. Now we will do our next question number, and yes, try to do this type of sum. I found that miscellaneous is important for the examination point of view, so that's why I want to do little more sum from this one. Now we will do question number 20. 20 it is, you will find that it is written 20 integration root over 1 minus root x divided by 1 plus root x dx. Here what to do? You have to think that what can I use for this one. Definitely here this can be solved if root x is what? X square. So we have to put let x is equal to cos, suppose it is 1. better, if we put cos square y, then we will get a better result. So for that I will write as cos square y is the value of x. Why cos square y? Because root x is there. So automatically if we differentiate, then it will be dx is equal to twice cos y and minus sin y dy. So this is the thing. So again you have to think why this root x is cos square y, because that we need to do something this one. So that's why if we get only one minus root x 1 plus, and then only we can be able to do. So now we will put the values. It is root over 1 minus cos y and it is 1 plus cos y. Here minus 2 cos y sin y dy. Then we have value what? That this can be written as 1 minus cos y. We can write 2 sin square y by 2, and it is 2 cos square y by 2 dy, and it is cos y sin y dy. 2 cancel, square and root will also cancel, and we will get as term minus 2 integration. See, as we can write, this is what? That cos y is 2 cos square y minus 1. So automatically we can write this thing as sin y by 2 cos y by 2 cos y, and this one is 2 sin y by 2 cos y by 2 dy. These two will cancel. Now we will get the value as 2. This 2 and that 2 will give 4 integration. Sin and this sin will give sin square y by 2 and cos y dy. Okay, now this is cos y. So now we are going to do remaining part. Now as it is minus 4, if I take only minus 2, then this becomes 2 sin square y by 2. 2 sin square y by 2 we can write as 1 minus cos y, yes, then only cos y dy. Now we get what? Minus 2 integration cos y dy plus 2 integration cos square y dy. Now integration of cos y is sin y. This one we have to use something, that we have to use the formula 2 cos square y can be written as 1 plus cos twice y, as dy is there. Now y we will replace as cos square y is x. So automatically from that we can write 1 minus sin square y is equal to x. So sin square y will be equal to 1 minus x. So sin y will be what? That is root over 1 minus x. So this is our sin y. Now integration of 1 is y only. Integration of cos y is sin twice y, whole thing divided by 2 plus c, minus 2 integration 1 to square root x. Y is our what? Y is cos inverse root x. Why? Cos y is root x, so cos y is root x, so y will be cos inverse this one. Now sin twice y by 2 can be written as sin y cos y. Sin y is root over 1 minus x. Cos y is what? Root x. So this is our solution. This is the answer of question number 20. Now we will do question number 21. So it is of course a thing that we should use this 21 is little bit that type, so we are going to do question number 20. 21 is integration 2 plus sine twice x divided by 1 plus cos twice x dx. My suggestion is that 1 plus cos twice x we can write as what? Sec square, that is 2 cos square x. So 2 plus sine twice x can be written as 2 sine x cos x, and this one is 2 cos square x dx. Then if we break 2 by 2, then it will be 2 cancel. 1 by cos square x is sec square x dx. This is our first part. What I have done, 2 by 2 cos square x, 2 cancel, 1 by cos square this one. If we divide these by these, 2 cancel, cos cancel, and we can write integration tan x dx. Integration sec square dx is tan x. So we are able to write, and integration of tan x is log modulus sec x plus c. So this is our question number 21. So many questions are there, so we can able to do every type of question like that. If we do seriously all the sum, then we will do question number 22. 22 is integration x square plus x plus 1 divided by x plus 1 whole thing square twice x plus 2 dx. So this we are going to do now. This is of course a case of integration by parts, but how to do? So to do this one we can write as what? Let this 1 by x plus 1 square into x plus 2. This you can write a by x plus 2. Then b by x plus 1, c by x plus 1 square. It is by partial fractions property I have written. So we get this one is a x plus 1 square plus b x plus 1 into x plus 2, then c only x plus 2. Now if I put the value of x as what? This one, for different values of this one, for x equal to we will put minus 1, then we will put x equal to minus 2, then we can equate the coefficient of this one. For that we will get as value of a is minus 2, yes, then b also we can able to calculate as 1 and c as 3. So this is b we can calculate as minus 2. Here if we do this one, is automatically if we put minus 1 we can also change this one, and here that is a that is c, you can get this one as 3, and automatically our this value of c will be 1. So this can be written in the form as like that: minus twice x dx by x plus 1, then it is dx by x plus 1 square, and then integration. Just by putting the values of this one, we can get 3 by x plus 2 dx. Now, if we do the integration, then we will get this one is minus 2 log modulus x plus 1. This one can be written as minus 1 by x plus 1. You can check this one. This is again 3 log modulus x plus 2 plus c. So this is the answer. And yes, this way we can do. Now question number 23 we are going to do. What is 23? 23 is integration tan inverse root over 1 minus x by 1 plus x. When this type of sum is given, then you should concentrate that thing. You should think that what we can write so that we can get the values of this one. Here main problem is to remove tan inverse. So if I put x as cos y, then automatically dx will be what? Minus sin y dy. So we can write tan inverse 1 minus cos y, 1 plus cos y, and here minus sin y dy, minus integration tan inverse. Here it is 2 sin square y by 2, 2 cos square y by 2, and sin y dy, minus integration. If I remove this, what we get? Tan inverse. We have to clean this one because we need this place. We need the tan inverse tan y by 2 and here sin y dy. Tan and tan inverse will cancel, and half if we take, it is only y sin y dy. Then we have to use the property of that one, integration by parts. If we integration by parts, if we use, here it will be keep y and integrate sin y. Sin y integration is minus cos y, okay, minus integration. Differentiation of y is 1 and integration of sin y is minus cos y dy. So we can get, by removing this bracket and putting the values, we get y is what? Cos inverse x. Cos y is what? X. So put here x minus half. Integration of cos y is sin y plus c. So we get x by 2 cos inverse x, and see cos y is this. So sin y will be what? Root over 1 minus cos square y. So it is x by 2 cos inverse x minus half root over 1 minus x square plus c. So we have completed so many sums we have done, and I expect you will complete the remaining one. Any doubt you can ask, and with that we end our integration. So today as the last day, I don't want to give any homework. Only your homework is that, okay, so without homework it is not looking good. If I write here in place of suppose cot inverse, then what will be the value of this one? Can you do this one? So this is your homework. So that much for today.